In the kinematics, so what we did was the definition of velocity, acceleration. So I'll try to explore more about acceleration, which you also need in the chapter of circular motion. So I'll try to get it down here itself. So what acceleration represents?
Tendency to change the state.
Correct. So acceleration is the, if something is having acceleration, it means its state of motion cannot be constant. It will keep on changing. And state of motion we represent by the velocity vector. So when I say change of state means change of velocity vector. So any change in velocity vector, either by change of direction or change of magnitude or both, will lead to the acceleration. And now because we have two particular ways of changing the velocity. One is you change the modulus. So when you change the modulus, or when you don't change the modulus, but change the direction. So let's say if we have a situation in which the mod is constant, but V is not constant. And there's a case when mod of V is a variable. So when the modulus itself is variable, then it will lead to some sort of acceleration, which we have a particular name called tangential acceleration, right? So let's say if we draw some random path, and we call this as curvilinear path. And if a particle is tracing this path, then even you try to keep the mod of V constant, let's say if you're not changing the speed, but can we prevent the velocity from changing? No. So what we need to remember that velocity vector is always going to be parallel to the path, or you can say tangential to the path.
Tangent.
Yeah. So we cannot change because as you move along this random zigzag path, one thing that is bound to change is the direction. Okay. And whenever a particle is performing the curvilinear motion, which is the tendency, this is a very generalized 2D motion, which could be 3D also. But if it is not 1D motion, if your direction is not constant, in such case, one acceleration that we must have is the acceleration by virtue of change of direction. So the acceleration that we develop by change of direction, we have a name for it. Okay. So the acceleration, of course, will have a simple definition. It will have two definitions. One is called the average, other is called the instantaneous. And when I say the word acceleration, I mean to understand only the change of velocity, nothing else will come into picture. So a vector, when I say the average, it is the change of velocity upon the interval. So when we have the big interval, we call average. But when we say the word instantaneous, it is the average velocity when the limit of time tending to 0. And this we write by the definition dv by dt. So what this A is called? So A is called the total acceleration, right? And what is A here? This is also the total acceleration, but this is the average, or you can simply say average acceleration. That's it. In curvilinear, we kind of distinguish the two types of acceleration. One, which is by virtue of change of direction, another by virtue of change of magnitude. Okay. Now, in a curvilinear path, is it possible to change the direction without applying any force? Is it possible? No.
No.
So to change direction, what we need? to change direction, we also need some force. Okay. And the force will,
Perpendicular force.
yeah, I mean, just force. I mean, of course, force which is having some perpendicular component. So let's say if I apply force like this, let's say some imaginary force is acting this way, which you don't see. Then this force will have two components. One,
Then it will also change the magnitude of velocity, right?
correct. So it will have two components, one F cos theta and one F sin theta. Only the tangential component can either speed up or slow down depending on the direction, whether it is supporting or opposing. So the force which is tangent to the path will create the tangential acceleration, and the force which is perpendicular to the path cannot change the magnitude, so it will only help in changing the direction, and that is called the centripetal force. So the word centripetal means it is acting towards some center, and for curvilinear motion we know that every point will have its own radius of curvature, every point will have its own center of curvature, right? So we have something called curvature. So the word F sin theta, we say that this is centripetal force, and this is called the tangential force. And they have different role to play. So the acceleration in the tangential direction is having a simple definition. If you again define the average, it is delta of mod of upon delta t. That's very simple. And if you want to define the instantaneous, then how to define? D by dt of what? D by dt of mod of v.
Mod of V.
So that's very simple. You first find the modulus and just find the rate of change. What we get is the tangential acceleration. So there is no like super concept. It's a very simple concept. And how to understand that which force will do it? So the force parallel to the path can do this. So let's say if we have a pendulum suspended and we have a string attached to a bob. So I think the path of the ball is well defined. We know the path of the bob is going to be circular, right? Without any doubt.
Yes.
So luckily we know the path. So it is like, although I have not mentioned this explicitly, but we have the fair idea about the path. And therefore, the force which is parallel to the path can only create the tangential acceleration. So if I draw the ABD and if I say this is gravitational force mg, this is the tension force T. So which component can create a tangential effect? Can we have the component of tension along the tangent, along the path?
No.
The answer is no. So whether tension is acting or not, because of the direction in which tension is acting, it will fail to create any tangential effect, and therefore tension cannot create tangential acceleration in this particular case. Now we are left with only one force. Which force? So we are left with only one force, which is gravity. So the obvious question is, can we have the gravitational component along the tangent?
Yes.
And this will be how much? Mg sin or cos?
Fine.
And this will be mg
Cos.
cos. Now let's talk about the tension T and mg cos theta. If T is bigger, then the net force is towards the center. Okay.
Yes.
And if mg's cos theta is bigger than T, it has to break actually. Or if it is not breaking, then it should be something like it will have the curvature this way. If mg cos theta will be dominant, then it will have the curvature downward. But if T is bigger, then the curvature will be upward. Okay. So that is the case. Like we need to understand that which way the force will have the net value. I mean, it's very obvious that if you are performing a circular motion and if you know the center already, if the center is here, it means the force acting towards the center must exceed the force acting away from the center. Then only this kind of center is possible. And therefore, we say that the net force towards the center. What is the net force towards the center? T minus
mg cos theta.
I mean, there's nothing big deal. So this is the net force towards the center. And when you write the net force towards the center, you equate with what? Because this force cannot change the
Tangential
magnitude.
velocity.
It will only change the direction. So I cannot write MA. This is wrong. I cannot write MA. So the problem is net force equals to MA, but which MA? We can only write MAC. The force which can change the direction, that force is called the centripetal force, and it will create an acceleration called the centripetal acceleration. Now, the problem is we don't realize that this is not the equation of Newton's law of motion in vector form. This is the equation which you are writing in one particular direction. So what we are writing here is the component. So if I actually write T vector plus mg vector, then I can write, what I can write ma vector. This is the actual way of writing Newton's second law, that net force equals to mass into net acceleration. What we write here is not the net force. We're writing here the net component in one particular direction. And when you have the selection of direction, then you cannot write the acceleration, you can write the acceleration in that direction. This is what you are supposed to write. So T minus mg cos theta we write as MAC, or T plus mg equals to MA. And also you can see that along the tangent, which force we have?
Sine con.
And this force will change what? It will change the magnitude or direction of both.
Magnitude, sir.
Only magnitude. So this will be equal to mass into the acceleration which is developed by virtue of change of magnitude. So I have to write MAT, and therefore the M gets cancelled. So we say the tangential acceleration is G sin theta. Okay. So what we write and why we write, that should be very clear in your brain. Okay. For example, if I give you a question like this. So if I say that, okay, a particle, and this is a very typical question which I take in every lecture. So a particle is moving in such a way that its position at any instant can have a parametric equation equals to t square and 2t. So this kind of parametric equation will lead to what? This is the equation of parabola. So in fact, I can clearly see that it will have something like this. The path is going to be like this, isn't it?
Yes.
And the coordinate we can say x is t square and y is 2t. Okay, so the t is how much? Y by 2. And I can substitute here to get the parametric equation. So I can write, and t here is, let's say, time. So now if the parametric t, the t is parameter, but here I am taking t as time. Okay. So the y becomes how much? So sorry, x becomes y square by 4. So this is the y square equals to 4x. This is how you create the equation. Although what you know is the time relation. The same question can be asked to you in this way. Let's say the r is the position vector of the particle, and the position vector is written as t square I cap plus 2t j cap. So the moment you convert the or express the coordinate by writing in terms of I cap and j cap, then what you get is the position vector, and it's a function of time t. So if I differentiate the position vector, what I'll get? The rate of change of position vector is called
Velocity.
velocity. That's simple definition. It's called velocity. So it will be v vector, which is how much? 2t I cap plus 2 j cap. And
Yes.
if I differentiate the v vector, what I get? A vector,
2 I cap.
which is 2 I cap. And what you realize from here? That a vector is what?
The total.
Constant. Which means at every point, we have an acceleration like this. having value 2. So I know this is the acceleration actually, which is 2. And the direction is constant, which means it is acting in this way only. Okay. And then I can draw a tangent and I can do a lot of stuff here mathematically also. So I know this is tangent. If I say this is theta, so this is also theta. And then I can draw the ABD of this particle and I can do a lot of things. Now the question is, we know what is the tangential axis. What is the AT? AT is how much? What is the tangential acceleration at any instant?
2 cos theta.
It is 2 cos theta. And because I know the tan theta, you know how I know the tan theta? Because I know that tan theta is y by x, correct? Dy by
Yes.
dx, the way you want to write. So dy by dx is as good as writing dy by dt upon dx by dt. This is how we solve the parametric differentiation, right?
Yes.
And if this is the
Yes,
parametric differentiation, then I know what is y. Dy dt is 2. And this is 2t, right?
1
Because
by
it's 1 by t. And because I know tan theta is 1 by t. So I know that I can draw a triangle. I can say theta p by b. This is 1 plus.
parabola.
Then what is cos theta basically? It is t 1 plus t squared.
Yes.
I can clearly solve this question with ease by writing 2 t by 1 plus t squared. So this is the time dependent tangential acceleration. Do you realize this?
Yes.
How we
Yes.
can take advantage of trigo, calculus, and everything else. If I know the direction of acceleration, it is really easy. Now, this is one way of solving, the very faster way. Now, if I don't get, if this is not getting clicked in the examination, what would have been my approach? So my approach would have been different. So I will do something differently. What I'll say is, I know the V vector. And I'm not supposed to, digress from the concept to create the answer. I will just go through the definition. I know what is mod of V. So mod of V turns out to be how much? I hope this is correct.
Yes.
So what is the definition of AT?
Very.
So you simply differentiate. And 2 into 1 by 1 plus 2, 2 square into, all right. Am I correct? And you can see the answer is coming 2t by. I think answer is same. You can check. So many times we are good with calculus, so we use calculus. If you are not good with calculus, we go through the definition. The idea is, if you are really good with the definition, you will arrive at the answer without much trouble. I mean, you're not supposed to think a lot. In examination, we have to develop a process called a generalized process. And then, of course, the trick part is always there. But the guarantee is not that it will click that fast. Because there is no guarantee that you are able to draw the diagram this way. So if you don't know how to draw the diagram, because this part is the most challenging part. Because what they will give you this equation. Now from this, you could have thought this way also. You could have thought this way also. There are many ways of thinking. And that's why I say the kinematics is very interesting. Okay. And luckily, because we know the acceleration. What is the total acceleration? Modulus? It is 2. And because AC and AT are mutually perpendicular, if I say talk about the AT and if I talk about the AC, they are mutually perpendicular. So the total must be somewhere between, isn't it?
Yes.
And therefore, I mean, I'm not supposed to think much. I know that the total is always the sum of these two. And because this is easy to find, we can find AC. Because you might be thinking that's the radius. And if radius is not given, then how to approach it to get AC? So we have the definition. So something which we can derive and something which we can't derive must have some relation. So this is how you think. And then you can say AC is basically A square minus AT square. And we know both answers. So we know this is 2, I think 1 minus t square by 1 plus t square. I think this is correct. Yeah. So our answer is how much? 1 plus t square under root. And see, you got the AC. And once you get the AC, what is the radius of curvature? So it is the net velocity square upon AC. And that is how you get the radius of curvature as a time function. And V is well known to us. V is how much? It's 2 into. Am I right? And AC we got. How much we got AC?
2 by under root.
Where is 2? Yeah, it's AC is 2 by 1 plus t is correct.
Yes.
So what we are getting here?
2 into 1 plus t square is to 3 by 2.
So you can get this answer. But let's say if you don't want this answer, you want something more answer. So there is a third way of thinking. So when we know the equation of path, pardon? Pardon? I think someone said something. So if we have the y square equals to 4x, then we know the radius of curvature definition 1 plus y dash whole square power 3 by 2 upon
I double dash.
Wide.
Mod of that.
and what is y here? So y is I think 2t, right? So what is y dash?
2.
Just I think y
Sir,
dash
Wait,
is,
that will be a mistake then, no?
no 2t square. It's t
Sir,
square.
It's
T
T.
square,
Just no, just no. No, this is not this. We have to find the equation of path, which is y square equals to 4x. So what is y dash? 2y.
dy by
Y dash
dx.
is 4.
Uh,
So y dash is actually 2 by y. And what is y double dash?
minus 2 by y.
It's minus 2 by y square, right?
yes.
And y we can substitute as a t function later on. Okay. So rho turns into 1 plus y dash square, which is 4 by y square,
Raised to 3 by 2. Upon 2 by y square.
2 by y square. So y square by 2 into y square plus 4, 3 by 2. And then upon how much? Y cube.
Yes.
So it is y square plus 4 power 3 by 2.
Sir, y double prime should be minus 2 by y square dy by dx. Right?
Yeah, correct. Which is y dash.
Yeah.
So y square into y dash is how much? 2 by y. So it is 4 by y cube already. Yeah, that's correct. So now this term will become how much? So this is already 4 by y cube. So y cube by 4 into y square plus 4 power 3 by 2 upon how much?
Like you.
This gets cancelled. And now you can substitute y. Y was how much? 2t. So I can take 4t square plus 1 power 3 by 2 upon 4. How much is that? 8 by 4. And so you can see the answer. Long way of doing it. But if you can understand the diagram, so in physics, every situation should be expressed in diagram. It's a question of kinematics also. It's a question of circular motion also. It's a question of vector also. It's a question of dy by dx as a rate measure also. So in kinematics, especially, if you're good with the vector representation, if you can express everything with arrow, with proper triangle law, a lot of things becomes really easy. I mean, you will be at ease of getting the answer with least possible effort. So this is what you have to discover, not solving blindly. When you solve even a question, because you all have solved a lot of questions. So now the time is like demands the realization part with whatever you solve, can you realize it? What you did, you must have the reason going backward that what I did and why I did, and what could have been done. So this exploration is required to crack any tough competition like JEE Advanced or Olympiad. The realization part. I have seen that many of us only solve because it is solved this way. Why? We don't know. And the same thing happens in other subjects also. It's not only limited to physics. It could be limited, I mean, happen in mathematics also. And it is even more required, like the way you solve. Anyway, so acceleration is an idea, and you're not supposed to always be seeing the circular motion to apply the concept of circular motion. Any path, any equation can have this kind of question, and it is always preferable to first you solve the situation. So there's a very nice question that I would like to give. So you all have heard of?
Yes.
Yes.
So let's go to question number 1.38. Euro. 1.38. Try to read the question and okay. Just no, just this is question number 1.36. Sorry. 1.36. This is the question 1.36. And in Erodov, you can see there's something written like this equals to a bold alphabet.
So vector notation, right?
Yeah, so in bold, it's actually dot product. So you can convert this into it's a dot. This is called dot product. And if something written like this in bold, this is called cross product. But anyway, let's say in the JEE, they will not give this notation, they will give you proper dot product. No need to worry. But you can solve this. So don't try to solve, try to proceed as per the problem statement and make sure that you have some relevant diagram. I think diagram is in fact shown to you. So take the diagram and then think about it. You will get some idea. So solve this. Do I need to send the question or you have the book?
Have the book.
Okay.
A particle A moves in one direction, right?
So everything is written there. So yeah, this
Hmm.
question is a particle A moves
Ah,
in one direction.
yes.
Yeah. But it is one direction along the trajectory, some random path. Okay, done. So try to bring the concept of elementary while solving. Think about elementary movement. In kinematics, it is very essential that one should write the things for elementary movement. For big movement, we don't know the formula. But for elementary movement, we know everything. Done?
Done. Sure, we can use A equal to V dV by dx, right?
Of course, which A?
Yes.
AT.
AT, yeah. So AT means the dV by dt and dV by dt. So V is the magnitude, right? And then what you
Yes.
did?
Then we can integrate it V dV equal to A dx, you can write, right?
A dx.
Yes.
No, I think they are getting something wrong.
No,
No.
I'm using V dV by dx is equal to A.
V divided by dx is not A. No, I don't see A. Which A? V divided by dx is AT.
AT. Yes. But
Tangential
V-
acceleration.
Yeah, so you have to say it correctly. If you say A, it's
Okay,
meaningless.
okay.
Because A you don't know. Do you have any idea of A? The answer is no. I think AT is given, right?
Yes, sir.
Yes.
A is not given. And here A is like some sort of constant. It's not acceleration. Okay. So V d by dx is AT. And AT is how much? And should we write dx here? Is it correct to say dx?
No.
So what we
We
should
have to
written?
write DSC.
Yeah, we should have written
SS.
V dv by ds. And ds will represent the length of path.
Yes.
So what you're getting is V dv by ds equals to some constant cos theta, right?
Yes.
Yes, sir.
So V dv is a ds cos theta. And what is ds cos theta?
Yes. That is basically dx.
That is
Correct. So now your job
So
is
now we
simple.
can integrate V square by 2. So V would be under root 2AX.
Correct. So you can see that it seemed initially a problem which cannot be solved. But once you know the how to write, see, you cannot predict the answer, or you should not know the answer. You write something and from there you try to guess the next step. So this approach is required. I mean, you're not supposed to know the answer. You're supposed to only know the process. So you start any question, you read it, you write what you see the first step should be. So we have 80 given, so we should write the definition. Now, how to write the definition in terms of position, in terms of time, these all we have to figure it out while solving them. And if that is there, if we know how to do this part in every question, then it doesn't matter whether it's a JEE main or advanced question, all are same. So advanced is as good as main. There is no difference. If this is the approach, if your approach is something else, then advance is very difficult and mains is very anyway. Solve question number 1.34. Solve 1.34. This question is clear to all of you guys?
Yes.
Yes, sir.
Yes, sir.
Okay, very good. Solve 1.34. Time starts. So after 4 minutes, I'll solve. So read fast, think fast, write fast, and write correctly. Create artificial pressure while learning itself. Only 4 minutes left. I mean, 3 minutes, 30 seconds. And I have a timer on. Three minutes left. Okay, 2 minutes left.
First one is done.
Good.
A part, B part, no.
Only 1 minute left to solve the A part. Read question, follow the definition, follow the information given, proceed and get the answer. You need to think that where you have solved this question. Okay, so 4 minutes is over. You need 1 more minute?
Yes, sir.
Done.
Very good. Okay, 4 minutes is done. So just you send me the answer. Let me see what you have done. Send me a solution quickly. Okay. Very good. The first part, second part.
And total basically we can take their sum, right? Vector sum.
Do it now. Tell me the answer. End answer.
Achha,
Whatever you have to do, you have to do it and tell me the answer. What is AT? What is AC? Done, everyone? Okay, I think now I have to solve this more than 6 minutes now. So in the 1.34, something is very clear. The Vx is given AY. And the rate of ascension is constant, right? And that is V naught. So you can clearly see Y equals to V naught T.
Yes, sir.
You can substitute here, this is.
AV not.
And you can differentiate this because Y is constant, so Vy is, sorry, yeah, this the rate of ascension Y is constant, V is constant. So the Vy is V naught and AY is 0.
0.
And AX is AV naught, right? So we have only X component of accession. There is no Y component, isn't it?
Y component. Yes, sir.
So there are many ways of thinking. I don't know which way you have gone through. We know the path is going to be like this. Okay. So because we have Vx, we can find the X also. So dx by dt is how much? So X will be a V naught T square by 2. And Y is already V naught T. You can substitute T from here because this is a parametric equation. So X equals to a V naught by 2 and T is Y by V naught whole square. That's it. So Y square equals to okay, it's 2 V naught. So 2 V naught by A, right? Into X. So this is the Y and X relation.
Yes, sir.
And this is again going to be parabola. And I can again clearly see that this question is similar to what we solved. So here the A total accession is only AX because there is no AY. So A itself is AX here. And because only X component is there, so why there is no Y component. Now this is the easier way solving. So you can take as theta. So what is AT?
AX.
What is AC? And the only thing is you are supposed to find the theta, tan theta. And it is always defined in kinematics, we define as Vy by Vx, right?
Yes.
So tan theta is Vy by Vx because the velocity is along the path, no?
Yes, and
So-
we know Vy.
Yes,
Yeah.
sir.
So we know both values. And why I'm writing? Because yeah, the answer is because we know both values. So I know the tan theta is Vy, which is V naught, and Vx we got AY. Correct? And we are done.
Yes.
And because I know tan theta, I can draw a triangle. I can set it as and my job is done. I got both the answers. A cos theta. What is cos theta here?
AY by under root.
So if you're not getting this answer, it means it's still one approach is missing. Like how to tackle from there. AC is how much? A sin theta, which is this clear? How to approach?
Yes, sir.
So this is how you have to figure it out. If not this method, then you have to go from here. You know how to use a differential equation. Correct? So differentiate the function, get the first derivative, second derivative, and put in the okay, no, so that is not required. So you can find the AC is centripetal is by definition is what? What is centripetal? The other way around is centripetal is how much? The net velocity square by.
Radius.
Instantaneous radius.
So that's very even that is complex. You can see. Because finding rho is a difficult task here. To use the entire question to get rho. But if you know this way of thinking, it is very easy question now. It is clear?
Sir,
Yes.
sir, can we use that definition of AC is V omega here?
Yeah, you can use it. But what is omega here?
So that's what I wanted to ask, how to find that.
Yeah. Of course, if you have tan theta, you can differentiate here. So too many
Okay.
equations. But there is a better way. I can get AT easily. Because AT is the rate of change of velocity magnitude, right?
Yes.
So this is the mod of VT. And mod of V we can find out because we know Vx, we know Vy. So mod of V is how much? Under root of. And my job is done. I could have simply differentiated this answer. I could have got this answer. Is this clear?
Yes.
And
Yes.
I know the total accession. I know that this is the total. The AX is the total because AY is 0. So I know A. I know A, I know AT because that's not difficult to differentiate. So it is twice of this into A square 2y, right? Into V naught. Do you see this answer? So this is the answer, right?
Yes.
So I think we have missed something here. Cos theta is how much? Something I missed maybe. Because I have to differentiate with time. Still going to dy by dt, which is A V naught. Dy by dt is V naught. This is not A, this is A itself here is, that's confusing. This is the A actually, the total A itself is A V naught, right? I hope this is, you are getting it. This is A actually, this is the total
Yes.
assessment.
Hmm.
And okay, because confusion came because of the AA symbol, which I kind of messed up. But you can see that answer will come in both ways. So kinematics is easy, but the application will be not as simple as that. And if you know accession, you know the accession is produced by net force. If you know total accession, you write the net force in total equals to mass into accession. If you know accession in one particular direction, so you write net force in that direction. And if you understand this simple concept, you know what is laws of motion. Okay. So you need to realize that a particle with velocity in a curvilinear track, the V is changing. And to change V, let's say if this something is moving this way, so to go this way, the net force should be this way or this way. Common sense. Up or down.
Up.
So why it is so difficult to understand that if I drop a bob, we know the curvature is this way. So the net force must be this way, no? So
Yes.
to turn,
Yes.
to turn this way, the net force will be this way. Why we are getting confused that this is also possible? So if something is moving, let's say if I have a spherical wedge, if something is going this way, so the net force will be this side or this side?
Downward.
Downwards. If I have a curve like this, and if I drop a ball, and if it is going this way, the net force at this point will be this way or this way.
Northeast.
So the idea is simple. How is it so difficult to write laws of motion? Do we need to learn the laws of motion at all? If you have a common sense, you can solve any question of laws of motion. That doesn't require any effort. So that is how we, approach physics. We don't approach physics by chapter. Just go through concept. If you're good with one, then it is simply a kind of a routine job to write and get the answer. It's a routine job. So if you look at the 60% question of JEE-Advanced, it is routine job. They create 20% question really challenging, so that all should not get the full marks. I mean, they don't want everyone to solve every question. But to qualify, you need even just more than 50 to get a good rank. So your chance of qualifying JEE-Advanced is much higher if you understand only concept. Okay. So let's say if I drop a ball from here. Okay, this is a circle of radius r. And this ball is initially at the horizontal position now. If it is coming to this position, there is no friction at all. This is theta. So you release from rest, and now you're here. So when you are here, do you have some velocity, or you are at rest here? What will happen at this point? You will have some velocity, yes or no?
Yes, sir.
And if you will have velocity, it means your path is going to be which path? Is it straight line path or curvilinear path? Rectilinear, curvilinear.
Curvilinear path, sir.
And in curvilinear, we have to solve question in two directions: tangent and center.
Normal. Yes, sir.
Normal. So if you draw the ABD, every force. That should be very much obvious that this is the normal, this is the MG. So I need to resolve forces either along the center and tangential. I can see clearly MG will have component along the tangent. Before that, I need to know the angle first. This is theta. This is how much? Theta. So what is the force along the tangent?
G cos.
And this is normal. So what is the net force towards the center?
And minus G cos. MG sin.
Minus.
Sin.
Yes, say it clearly. Why you're hesitating? So net force towards the center. So you're turning this way, no? Your center is upward. You should clearly. This is clearly visible. So net force towards center equals to. Can you write M into A? Is this correct? You write.
No,
Can you write
sir.
the net acceleration? That's wrong. So which acceleration you write here?
Centripetal.
Because this will only change the direction. So this is a centripetal. We know the formula for centripetal. Because the path is well defined, so we cannot. This has V square.
Yes.
What is the problem? I don't know what is the problem. Like, do we really need to learn this chapter? I never thought that there is a chapter like circular motion. It is just a time pass. If you know kinematics, if you know basic laws of motion, this chapter is not at all required to study. And then you write, okay, no one will ask you what is the tangential acceleration. But there is a tangential acceleration as well, which is how much? Mg cos
Cos
equal to
theta.
how much? MAT. And therefore you have two types of acceleration. AT, which is G cos theta, and AC, which is directly, you can say V square by R. No need to write this side. If they ask normal reaction, I can compare across these two, because V square by R we can get from where? So from where to get the V? So if you descend from some height, you will have some V. And from where we can get V? Tell me quickly.
Conservation of energy.
Conservation of energy.
So we can know that loss in potential is gaining kinetic energy. What's the big deal? And how much energy is lost while come down? How much you have descended? How much you have descended? Tell me.
mg r
R
cos
1
theta.
minus
Sin theta.
mg.
It is
1
only r
minus
sin theta. So much confusion. See how much you have descended, which means what is the vertical motion? That's it. So you have only descended by r sin theta.
yes.
So how much potential have lost mgr sin theta, and the loss in potential is gaining kinetic energy. So I can clearly, or you can also clearly see that the v square by r is how much? 2g sin theta. What's the big deal? I can write here 2g sin theta, and then someone will ask you what is the a value. So now I can say a is at square plus ac square, and then you can see g common, and then 4 sin square theta plus cos square theta, which is like 1
1
plus 3.
plus 3 cos sin square theta.
Is this clear?
Yes, sir.
So
Yes.
whenever you lack a number of information, you have to think about new concept. So now the energy is the obvious concept which we apply in the vertical motion to solve the question. Of course, it's like missing parameter will be coming from there. And now comes the question, very interesting question from in the JEE, that if I have a pendulum and there is a bob, so as it will come down at some angle, so as we come down some angle, at some angle here, let's say by theta, it will have two axes, right? Which two? Centripetal like this and tangential like this. I hope you realize this.
Yes.
And the total acceleration will be somewhere in between.
Yeah.
So that they will ask you what is the direction of the total, or what is the direction of acceleration. Now most students they answer this. The direction of acceleration is something like this. I don't know where. I have no idea. So the question is, at what angle theta the net acceleration will be like this? I mean horizontal. Can you find theta when A is like this?
Yes, sir.
And you know what is the approach? When you know that a vector is in some direction, then the component of vector perpendicular to that direction must be zero.
Opposite.
And that's the concept again. And again, for that, if you know vector chapter, that is more than sufficient. You're not supposed to know any chapter for this question. And you should know that this is curvilinear motion, so I can only analyze things in direction wise. So you analyze things in AT, AC, and then you get A. So solve it. Tell me theta quickly. Concept is clear, guys? Tell me yes or no.
Yes,
Yes.
sir.
See, I'm just discussing acceleration. And there is no chapter in physics. So that's why I can go to any chapter and I can start explaining the concept of acceleration.
So tan inverse half.
Yeah, I think either 2 or half should come.
I think it is half.
That should be the answer. So the answer is simple. AC. What should I write here?
Sin theta.
Equals to.
80 cos theta.
Yes.
So basically tan theta is how much?
80 by AC.
80 by.
And what is going to be 80 here?
G sin theta.
So 80 will be G. Huh? 80 is how much?
G sin theta.
80 is G sin theta. Are you sure?
G cos
T
theta,
minus
na?
M.
But yeah, Hasika, tell me what you said.
Sir, 80 T minus mg sin theta.
80.
All right. 80 is mg cos theta. Sir. I mean, mg cos theta by m, which is g cos theta.
And what is AC? AC we can find directly by finding the velocity, right? V square by L. So it is always V square by L. That's simple. And we
Yes,
know
sir.
how to find V. So here V square by L is how much?
2G sin theta.
2g sin theta.
2G sin theta. And if you substitute, what you are getting? So tan theta is G cos theta by 2G sin theta.
So
So
tan
tan square
square
theta is
theta is
1 by
half.
2.
Half.
So tan theta is 1 by root 2.
Yes, sir.
You guys said 1 by 2. That's incorrect.
Sir, I took 80 as G sin theta.
Yes.
Basic concept. You have to understand only basic concept. So physics is, of course, it's called the full of concept, but not the way you have thought about physics. So we have transcended from the kinematics to circular motion chapter and the laws of motion also, dynamics also. And there's a very smooth transition. I mean, we are not supposed to learn the chapters. We know the concept, we can apply the ideas, and mechanics is something which can give you the answer. Okay. So let's go back to some more intricate kinematics question. So in kinematics, most often we find projectile interesting, sometimes easy, sometimes difficult. So we'll try to understand projectile motion. So of course, there are some definition. What is projectile motion? So in our context, first of all, we need to understand that a projectile motion is basically a parabolic path. Okay. And there are many contexts that you need to understand. So if we talk about the projectile motion in case of chapter of gravitation, when we launch, kind of satellite, and let's say the satellite fails, it doesn't escape the Earth orbit. So if we have Earth, you launch a satellite, like Elon Musk launches a booster satellite, I mean this launching vehicle. And what happens, it goes, and then, it releases the satellite and comes back. Now, when we have a motion of this nature, can we take the gravity as constant?
No.
Can we take gravity as constant?
No.
And when gravity is not constant, so this cannot be a parabolic trajectory. This is basically ellipse. So if you have studied the gravitational chapter, this is ellipse path. So if you throw something with velocity less than the orbital, it will follow the elliptical path will come back to Earth. So are we going to learn something like this here? The answer is no. So what we're going to learn? We're going to learn something called the constant field motion. So what is constant field motion? Any motion which happens under the influence of constant field. Now, when we say the field is constant, so here the meaning is when the force of the field is unidirectional. And it is not only unidirectional, it is constant in magnitude and direction both. When the force acting on a moving object is constant in both magnitude and direction both, then only we talk about the projectile motion, then only the formulas are applicable. If we have such a huge trajectory, the gravitational force will act in different direction. So is this motion constant field motion? And think more than field, I should add constant force. Constant force field motion. This is the bit to go. So in this huge trajectory, do you see the force as constant? And the answer is no, it is neither constant in magnitude nor in direction.
Yes.
Because the force will act towards the Earth center. Not in variable varying magnitude, but also in direction. So this is not we are going to discuss. I'm going to discuss what? A motion where the force is constant in magnitude as well as in direction. Every motion of that category can be called a projectile motion. And what is the criteria? Criteria is simple. The initial velocity should not be parallel to the constant force field direction. That's it. So let's say if I have a force acting this way, and this is some hypothetical field, and it is always acting in this way, constant value. If I throw something like this, so this is definitely not parallel to the constant force field. So the path that you will govern is going to be parabolic path. It is going to be a trajectory which will be parabola. So parabola having this characteristic, and if force is constant, then this implies what? The acceleration must be constant, isn't it? And you can clearly see in all the previous question, we had a constant acceleration. Do you realize this?
Yes, sir.
The total was constant, right? Here also, I think, here also. And you can clearly see all trajectories are parabola. That's very interesting. So a parabola having this very unique characteristic that a parabolic path is a path governed by all projectiles in which the force is constant throughout, in magnitude as well as in direction. Or you can say in which the acceleration is constant throughout, in magnitude as well as in direction. And that is the essence of projectile motion. Now it depends on which kind of force you take to describe the motion. In this chapter, we take the gravitational field or the gravitational force only.
But it could be any tangential force, right?
It could be any force, any not initial, any
Okay.
force which is not parallel to the velocity.
Yes.
Which velocity? Initial velocity. So the
Yes.
force should not be parallel to the velocity at the beginning. Then,
Otherwise, it won't change the direction only.
yeah, if I throw something, if I have a force this way, and if I throw this, if I throw like this, I cannot expect any path other than linear path or straight line path. Can we? If this is the only force acting in the universe, there is no other force. This is what I'm what I'm representing the net force. And if I throw something either this way or this way, do you expect any projectile motion? Common sense. Do you expect it?
No.
The answer is no. I mean, why anyone would expect a trajectory of projectile motion? So that's why we have a chapter called the motion, the gravity, like the vertical motion and the projectile motion as two separate entities. And the difference between the two is the direction. That's it. So it's like we have to throw obliquely to what? Obliquely to the constant force field system. That's the only criteria. There is no other criteria for learning this chapter. So where possibly we can create this chapter, so I can say that, okay, of course, in case of under the constant G, constant E. So you can see that this chapter will be come under two cases: a constant G, constant E, or the combination of the two. Let's say I can create E this way and G this way, and I have a projectile not with mass but also with charge. So the resultant of the two will be the new field or the net acceleration. Or you can say G effective we generally represent. And then I will check everything as per the G effective, and it will have a trajectory like this, like this, like this, or whatever. So the idea is the question that you can expect from projectile motion is not only G, it could be either G or E or combination of both. So this is the generalized picture. Like normally you start with only G, then in 12th you study the electric force, electric field. Okay. And then I can say that imagine I have infinite sheet. So I have infinite sheet. And if my sheet is infinite, and if I make it uniformly charged sheet, this is a indirect way to create what? A
Constant
uniform
field.
force field system. And gravity is also there. So imagine the entire sheet is horizontal. And now I have a charge particle, which could be positive charge particle, negative charge particle, or whatever. So imagine I have a negative charge particle, which I throw with velocity v at an angle theta. I can clearly see if the charge is q, mass is m, the net force is going to be how much? Mg plus
Mg
q
plus
in the downward direction, right?
Yeah.
Because the field is going to be like this, upward. How much field?
sigma
Field
by
is
2
sigma.
epsilon naught.
So my answer is mg plus q into sigma by 2 epsilon naught. And this is the m into g effective. I can create a new formula, mg effective. Then I have g effective equals to g plus q sigma by 2m epsilon naught. Once I get the g effective, and once we know that how to solve, in every formula of projectile motion which you have already studied, let's say time of flight, which is 2u sin theta, by g we have got g effective. That's it. I'm done. I'm done with the question, isn't it?
Yes.
So this is how you proceed. Like once you know the answer, then you know what kind of changes we have to bring to solve this question. So this is also your projectile motion. And they will mention that, okay, they'll give you this entire quantity is equals to g by 2. So that's easy for you. Let's see if I say q sigma by this equals to g. So they will mention, okay, take, and they will make it really nice. Then the g effective becomes g plus. Okay. So this kind of changes will come, but you have to proceed accordingly, that to correct the net force and so on. And that is why we learned the projectile motion in chapter of kinematics as well as in chapter of electrostatics. In both places I teach. And now comes the combination. So you have the generalized idea of any concept you can play with. Now, once this concept is clear, let's try to dig deeper into the concept of projectile in terms of approach. Don't try to, first of all, remember even a single formula. Only remember through practice, not through the, mugging of the formula. So let's say, what is the essence of solving problem? Okay, I have a tower. Okay, I'll start with the horizontal projectile motion just to start in a sequence. So let's say we have a tower. Okay. And you throw a projectile. So projectile motion only starts when it has left the thrower's contact. It may be a gun, it may be a person throwing it with hand. Okay, you may be kicking by a foot. There could be any process of throwing. You provide some impulsive force. The idea is, as long as it is free from the contact forces, it is under the influence of the constant force fields, then only the projectile begins. So when I'm holding with my hand, there is no concept of projectile. When I have released, now gravity will do its job, because gravity is the only field, only force field present here, which is constant in magnitude, and then it will do all the job. So the question is what job it will do. So gravity is able to create downward velocity, because acceleration is the ability, right? This is what we studied. What is acceleration? It is the ability to change the state of motion, and the motion state will change in the direction of its application. So if G is acting downward, so it will create velocity downward, or if you have already, it will change that value. So if you have, it's good. If you don't have, it will create. And because it is constant, so how much it will create velocity? Value wise, it is GT. Of course, it will be downward. I hope this is clear.
Yeah.
So there is no big deal. So
Yes.
if I throw with some velocity V naught or U, I don't know which symbolic notation you find most comfortable, U or V naught.
U.
We not.
So you both are having the trouble. Physics never says that you become comfortable. It simply says remember the concept. Why one should be comfortable with one formula or one way of writing? Any symbol should give you equal comfort. Okay, so I can create something, a symbol like a science symbol, and you will say, no, I will not study kinematics because the symbol is kind of, for vegetarian, it is like non-veg, or for something else, it's something else. I mean, you are not supposed to love or hate any symbol. Go by the concept, any symbol I can create. See, the Eurodov creates a really weird concept for acceleration, W. And the W, which is, kind of strengthened. They use phi more often, they use gamma, tau. So they have kind of, more liking towards the Greek alphabet than the regular alphabet. But that's okay. Okay, anyway, so I'll start with the which symbol? Okay, V naught. So you say, sir, you have also biasness. Okay, you. Okay, any symbol you start with. Okay, tell me, like, who changes the state of motion? We all know it is the force which changes the state of motion. Okay. And in which direction force is acting? The answer is downward direction. So which state of motion can be altered? The horizontal or the vertical? In this
Vertical.
case. So can we affect the horizontal component in the
No.
due process of motion? The answer is no. So gravity will create the vertical component velocity. It means that velocity will bring it down. Okay. So who will bring the ball down? Simple question. The gravity or the thrower?
Gravity.
So what is the role of V naught here?
To decide how far it will go.
The role of V naught is to continue in its direction with constant speed. That's it. Its role is to just keep on carrying that direction, keep on moving in that direction without any effect, without any change of effect. So gravity cannot affect the V naught. So you will continue moving in that direction, and then eventually you hit the ground. And when you hit the ground, what will happen? The V naught becomes. If we hit the ground, the V naught becomes. So what will happen to V naught once you hit the ground? Tell me.
It will still remain V naught, no?
Yes, it will always remain V naught unless some frictional forces are not coming into picture. So if there is no force other than gravity, if I'm saying that gravity is the only force, so there is no frictional force, there is no other force. So the ball will continue moving in the horizontal with V naught. If the surface is having some rigidity, it will bounce back also. If the surface will have some coefficient of restriction, then the bouncing velocity will alter a bit, but nothing will happen to V naught. Because even you hit the ground, the forces acting on you will be vertical only,
Yes.
isn't it? So nothing happens to V naught. So will it stop moving? The answer is no. After hitting the ground, it will never stop moving. It will keep on bouncing and, and going forward. Understood?
Yes.
Only if there is a coefficient of restitution, then it will have the lesser and lesser height. So it will eventually settle down. It will like tap, 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 and then tap, over. So the path is not only this way, it is hitting and then it will become like this and then like this, like this, like this. If there is a dampening happening due to the collision. If there is no dampening, then it will bounce back to a certain extent and which will repeat indefinitely. Okay. So we know the path. So we know the path is something like this. And any constant acceleration will have the similar feature. And it is also not required that we hit the ground. It's difficult. So what is our definition of projectile motion? What do we say? What is time of flight? What is the definition of time of flight?
The time for which it is airborne.
Airborne.
Yes, the time for which it is airborne. That's it. Nothing more, nothing less. So for the whatever time it is in air, not making any contact, that is the duration we call time of flight. Once you hit something, you make contact. You may again start the new projectile motion, but for us, the first projectile motion is over. And our analysis is generally if you solve question, you analyze for the first contact till you make first contact. The same question when comes in the chapter of center mass, then the projectile will be like up to nth collision. They will ask you find the time period of nth collision, like how, when you make n hits, how much time it takes to make n hits. Okay, so here we are only concerned about the one hit. They will ask you 2 hit or 3 hit or 4 hit or 5 hit or anything, 5th, 7th, whatever. So we have to be careful in the language, in a situation. And when they mention the coefficient of restitution collision, they use the word collision, then the question we will go from the kinematics to the chapter of center mass collision. And then we have to be more like concerned that what I am supposed to find, the time of flight for 1, 2, or 3, or 4. So right now the time of flight is for 1 by default. So as you move forward, you go downward and you go downward because of the gravity. Now, if you look at the formula of kinematics in vector form, so we have V equals to U plus AT. I have discussed this already. And then this I will change to V equals to U plus GT here. Now this is convenient because I know that the net acceleration here is due to gravity, so it's G. Then we have S equals to UT plus half T square, which we can write as S becomes the changing position vector, the displacement. So delta equals to UT plus half GT square. And these are vector notation. See, there is no minus here in vector notation. So when you write something in vector notation, then you are free from the using symbol minus, plus, whatever. And when you substitute into component I, J, K, then you have to put it. And what is interesting is that these two equations are very powerful. I can write this as U plus T into G vector. And the second write as T into U vector plus T square by 2. And it is like from chapter of vector, it's like lambda U plus mu G, right? General coplanar vector. This is all right.
Yes.
Yes, sir.
And here lambda and mu are variables or constant. Here lambda and mu are scalar variable. It's called scalar variable. What is scalar variable? Time is a scalar and it is variable. So here lambda and mu are scalar variable, which means this triangle will be having different length of sides as time will change. So in a simple, as time will progress, the two vectors will change its dimension. Hello.
Yes, sir.
Yes, sir.
So
Got it.
when t is 0, no matter what is g, when t is 0, it is a zero vector, null vector. And that's logical. At t equals to 0, there is null vector, nothing is there. So as t will progress, then these two vectors will grow in length. Same thing is here. The v vector is the resultant of these two vectors. But out of these two vectors, the second vector is a variable one, because the g is constant. And this constant vector is scaled by a symbol t. So if you know the vector, and if you know the concept of vector, you really understand, okay, these are growing vector. This is constant vector. This length is fixed. This length is variable. So I can have any length. Now, if you have that way of thinking, then these are two separate entities which you are adding vectorally. So we can say one entity cannot affect the other entities. Both are independent entities. Hello, yes or no?
Yes, sir.
So their working is independent. So the role of G is a very separate thing. The role of U is separate thing. Of course, what you see is the combined effect of the two separate events. So your perception is the net event. You cannot perceive the two events, but when we solve mathematically, I can draw the events separately. This is what we are trying to convey. So here, what is delta R here? Delta R is, this is a delta, right? Do you realize this is delta R?
Yes.
Because delta R is the initial and final. Okay. You say this is H. And then you say this is the range. I mean, this is what you say. So what is the range? Like, here the range is having very specific definition that the horizontal displacement is range. Is it displacement?
No.
No.
No, range is not displacement. So what is range here? It is the horizontal displacement in this context. So as the context will change, you have to understand the context and then apply the formula. Generally, the mistake happens when we forgot the underlying context in which something is being said by any teacher for a given situation. So more than formula, I always insist that try to recall and remember the context in which things are being said actually. And if you're not doing that, then you're missing the entire purpose. You're going to beat the entire purpose of learning. Context is very important. What we say and why we say and how we say, of course. So we have the range. What is the definition of range? If I ask you. So in this case, if I ask you to define range, put into words. Because if thoughts are clear, you can put into words. If there's no clear thought, the words are not going to come. Yeah, just tell me, what is the definition going to be? Define, guys, please define. What should be the correct definition of range? Anyone?
The horizontal component of displacement of the projectile.
That's it. Do you think something is missing here?
When the first time it touches the ground.
Express in a proper way. That's how you see.
Okay.
You're very close to the emotion, but the words are not sufficient. Darsh,
Yes, sir.
express it.
The horizontal displacement of a projectile during its time of flight.
Yeah, during the one time of flight. Yeah, so you can say it is the horizontal displacement during one time of flight, of course. Because see, after hitting, it is not going to stop. It will keep on jumping. So how many time of flight we're talking about? Just only one?
Yeah.
Because in two it will be more, three it will be even more. If you know something and if you have the right word to express, then you know. So many times we fail. And that is how we make mistake. R is having definition. Okay, anyway, let's say, okay, if you want to calculate the time of flight, then what is the ways of thinking to get the answer? What we should do? In this question, what is given to you? Just two things, or you can say three things. H, the height of the tower is given, V naught, the velocity of projection is given, and accessing is given to you, which is G here. So if you want to find the time of flight, what you do to get time of flight? Don't tell me the formula. What you do exactly?
Derive it using kinematical equations.
Pardon?
And we use the three kinematical equations to derive it.
No,
Basically,
that's a very rubbish definition.
Sir,
What you do?
the vertical displacement is equal to h, which means t square by 2 into g is equal to h.
No, there's nothing something like this.
Sir,
During the time of flight, the vertical displacement is equal to the
Yeah,
capital.
that is the concept. Well, what you said after that is not meaningful. The only thing you know is there is some very concrete information which you can fetch from the given event. That whatever is the time of flight, I don't know, but I think know that in that duration, I have traveled h in vertical direction. That is you have to pick actually. You all are picking the wrong thing. Okay, so you can catch a snake by not, holding the mouth, the neck or the tail. You know what will happen if you do other thing. It's dangerous. So here what is happening? It is coming down and we have to look for some physical parameter which is available or in which I can express the event. I know that whatever is time of flight, I know one thing, that in that duration, I actually descended h. And that is the only thing. It's so simple. Do you all realize this part, what I'm saying?
Yes.
yes.
The projectile has descended by h, that's the only information.
yes, sir.
Tell me any other information that you can see here. Think about the velocity of.
Nothing in particular.
You see, you will find yourself helpless. Nothing is actually there. It is so powerful that nothing is actually there. So the way you solve having the constraint, So the thing is, what I say is like, look for the constant in every motion. And I can see this is my constraint. This is going to determine the rest of the event. And therefore, now the question is, in the displacement relation, the U will try to take its in own direction, and G will try to drag you in its own direction. And what you know the vertical drag actually, how much you have to shift downward. So who will bring you downward, U or GT or both?
GT.
Like half GT square or UT
Half
or
GT
both?
square.
Half GT square. So I know that in time T, it is only the half GT square which can bring me down. And therefore my answer is 2H/G. I know this answer. I mean, this is obvious answer. I will not even write the entire equation to solve. Now I know that gravity cannot take me forward. So if I would like to look for the range, I have to first ask who can take me there. V naught, gravity, or both? And the obvious answer is
We know.
V naught. And what is the range definition? How much I would have traveled in one time of flight? And my velocity is constant in that direction or variable? It is constant.
Constant.
So I know that R is nothing but the velocity into time that I can travel for. All answers are coming naturally. If you can talk to each term, it will make some sense to you. Is this clear?
Yes.
Yes.
Does it make sense to you?
Yes.
Yes.
So are we supposed to mug up something? No. And then I suddenly bring some sort of wind, the sea breeze, the land breeze, whatever. And then I say, see, this land breeze is going to create one additional horizontal acceleration A naught. Now, will this affect this answer?
No.
No, sir.
Tell me. No. Because who has brought me down? It is still gravity. But who has taken me forward? It is not just V naught. Even this drag actually. And if I know the concept, I can simply write, oh, R is not only, this V naught. V naught can only take me this much. But in the same time, the A will take me this much. And I'm writing two things separately without looking for the kinematical equation. I really do not need to know the kinematical equation. I know this is how to write. Is this clear? Hello,
Yes,
hello.
sir.
Yes, sir.
And then one fine day you decide, no, I'll play with the God. I'll say, no, see, the air resistance, the air is coming this way, and then there is a blower you're starting, this is a movie set, and we have a fan, and you create it's a big fan. And then you create a air drag this way. A naught is acting this way. Ridiculous. And then A will have two components, like A naught cos alpha, and then A naught sin alpha. And then I will write, oh no, this will become A naught sin alpha. But the T will also change.
T will also change.
So I know that, oh, okay. Gravity will bring half G T square, but A naught cos alpha will take it upward, right? And then eventually I'll fall down by H, isn't it?
Yes, sir.
If you know the concept, any situation may come, you can start from the scratch and get the answer. And it will not demand you to know any single equation of kinematics. Does it require?
No.
No. Common sense is more powerful. Okay. So I had a student in class 8th. I taught him the same crucial motion, the same fashion, the way I'm teaching you guys. So when he was in class 9th, he solved the entire sigma with ease, without realizing what is chapter, what is projectile motion. You talk to each term, there is some sense, some meaning to it. And once you have the meaning, you can write in a way, then equation will become automatically. You can create any equation you want. So here is the question. The same question, let me do some more analysis. And the similar analysis will be for the other topics also. So I'll tell you where comes the intelligence, like where we have to be intelligent to solve question. There are places where we have to be intelligent. So again, you throw with speed u, this is a projectile. When you are here, we know the path represents this is the locus of points traced by the particle. So velocity vector is always, how v vector is? The velocity vector is always tangential to the path, if you remember, yes or no?
Yes, sir.
Yes.
Yes, sir.
So this is the v vector, which we don't know. Do we know? No. But we know two things. I know the horizontal component. I know this is always u because the gravity cannot change that value. And I know that gravity will give me something. And it will give you some velocity in this direction. How much? GT,
Yes.
isn't it? Because
Yes.
G acceleration is constant, so A into T is the velocity change. So if I had nothing downward, so what will I will have now? I will have nothing plus GT, which is GT only. And now if I say this angle is theta, so I know everything. I know tan theta, how to write tan theta. And how to write tan theta? What is tan theta? Tell me.
GT by U, sir.
GT by U. Done. Over. This is your tan theta. Now, if I ask you what is the centripetal acceleration, now let's change the direction. From solving kinematics, I go to the chapter of circummotion. Certainly, my mood is to find AC now. What is AC now? What is AC now? AC is the component of acceleration
G
normal to
cos
the
theta.
velocity. So it is G cos theta, right? Is this clear to all of you guys?
Yes.
Yes.
So G is acting this way. So the acceleration which is normal to velocity,
Yes, yes.
because only the perpendicular component can change the direction, right? So G is
Yes.
actually the total acceleration. Do you realize this?
Yes,
G is
sir.
not tangential or centripetal, it is the net acceleration. So I can clearly say AT is G sin theta,
Sine theta.
AC is G. And suddenly I got to know because cos theta I can find from here, because I can draw a triangle. And tan theta is opposite upon base. So I know cos theta will be base upon hypotenuse. So jump from one concept to other concept. And this is easy. It is clear. So you can express the centripetal acceleration in this way. You can express the tangential acceleration in this way. Hello, hello, hello. Is this clear?
Yes.
Yes, sir.
And not only this, if I say this as the x-axis, if I say the y-axis, if I say the origin and y-axis, then in the time t, how much you will go ahead? So your
UT.
horizontal movement is how much? And this is your x coordinate. So I can clearly write it x equals to ut. And to write your y coordinate, because this is h, and
H.
we know that you will descend by how much in time t? Gravity will bring you down by how much? Half gt square, isn't it? So what is your y coordinate?
H minus half GT square.
Is this clear?
Yes, sir.
and then you can substitute t, and you get the equation of trajectory, which is obviously a parabola. It's a quadratic equation, isn't it? Hello, hello, hello.
Yes.
And because x equals to ut, so I can express t as x by u. And if I substitute this into this expression, then tan theta we can also express in terms of x, g by u into x by u, which is like gx by u square. So if I know that you have traveled by x, I know what is the angle you have tilted. So you suddenly start creating a lot of equation. And not only this, I mean, if you're not happy with that, you can add what is du by dx. You can differentiate one, find it. So 0 minus g by 2 into 2x by u square. And then I get the answer, oh, this is gx by 2 by u square. And because it's an, I know slope is negative because you can see it's below the horizontal. So this is, so tan theta is basically minus d by dx. Yeah, we have to add the value only. No? So to write the value, I can write like this. Same answer. So yeah, I'm free to use the calculus also as whenever I need it. So you suddenly you start creating a lot of equation variables, and then you come here. And when you come here, then you hit, but you will remain same. And then this GT will become really longer because as t will grow, this will grow, isn't it? But this t will be time of flight, correct?
Yes.
Hello, hello, hello. It is clear?
Yes.
Yes, sir.
Yes, sir.
So you can clearly see that these diagrams, once you start drawing, you will get the more realization. So you may hit at angle alpha. So they'll ask you at what angle it will hit the ground. And you know the answer. The tan alpha is
GT
how
by
much?
U.
G capital T by U. Or G range by U square. Depend how they want to ask, in which term. So for the first time, you have to analyze. Now, if you have understood the chapter in this way, then there is nothing like projectile motion. Any question of projectile can be solved with extreme ease by proceeding slowly, logically. Is this clear?
Yes.
And then
Yes,
your
sir.
ability to convert from one form to other form and so on. So suddenly one fine day, you come across a new question. That this is a projectile. So we have an inclined plane, inclination is alpha. And then you throw something at a angle theta from horizontal with speed u. And it simply falls like this. And you become clueless how to solve this question. And you're supposed to find the time of flight. So do we know any parameter which can be deduced from here? So do we know the vertical displacement? Yes or no? Tell me. Do we know vertical displacement?
So, but for that, we will need time of flight.
No, do we know? I'm asking as of now.
No,
Do we know horizontal displacement?
no.
Nothing we know. So how we can solve if you have no information? See, we must be knowing something.
So we can write the basic equations of velocity and displacement.
No, we must be knowing something technically. So we have to solve analytically. So right now I'm not trying to solve in vector form, just analytically. What should be the analytical approach? Analytics means like, the component method. When I say analytical, it means using some component, some directional properties. Let's say I don't know the vertical or horizontal, but why we are looking for only vertical and horizontal? Why not in some other direction? That's the question. You have to question yourself. So then one fine day, what you do is you say, okay, I'll take this as a new axis. I'll call this as X dash.
Yes,
And
and we
then-
can resolve G in that.
Yeah, you can do a lot of things. See, you remember why? I was asking the same question. How you're going to solve? You know the process, you know how to solve means once you know this question, okay, this is what I used to do, so I will do the same thing. The clarity is still not there. Why you are doing the thing which you are doing so far? Is that clear in your mind? Have you ever realized that why you been drawing such diagram to get the answer?
Yes.
So that is important. See, the why should be very, very clear. So then one fine day say, okay, I'll choose this as y dash and x dash. I'll keep my x and y as such because that is also going to be useful. And then I will look for some new analytical parameter, which I know. So then what I know here?
We know G, sir.
What?
Say G.
Yeah, of course we know G. So how to get the time flat if only G and V not U is given to you?
Sir, we resolve G according to the new axis
No,
that
why?
we
Like,
have.
what do you know? What do you know?
Sir,
The
we'll
displacement
find
along y prime is 0, but
0.
Correct. So that is
Oh.
what I was waiting for. What you now know is that there is no displacement along the y prime. And therefore, suddenly now I have to resolve everything in the y prime direction, whatever I am looking for. And who will help you in bringing it down? What is the acceleration of velocity in that direction?
Sir,
So what is the
bringing-
velocity in that direction?
Sir, down with respect to x dash or
No. Component of velocity in the y prime.
u sine theta minus alpha.
Correct. But that will take you away from the plane or towards the plane.
Away.
Away from the planes.
Common sense. See, I'm saying u sine theta minus alpha. In time t, how far it will take you? This much. Common sense. So you have gone this much far away from the plane because of this component. Do you realize this?
yes.
Yes.
Nothing. But who will bring you back?
G cos alpha.
Cos alpha.
G cos alpha will bring back. So in time t, G cos alpha will bring down by how much?
Yes.
And however far if you have moved and if you come back by the same value, you
0.
are back to the same plane.
Yes.
I'm definitely using kinematic equation, but not the way you think. Am I talking about sign convention here?
What?
Am I talking about the sign convention? No. Common sense. Because sign convention is also common sense. Not a mechanical process. So now this is gone and I have the answer. What is the answer? And we all know this answer, isn't it?
Yeah.
And then suddenly I ask this question, can you find this range? Now range is again, I have to reconstruct the context. Range up the plane. Because in the previous question it was range in the horizontal direction.
Yes, sir.
Context has changed.
It would be u cos theta minus g sin alpha into capital T minus half g sin alpha capital T square.
Very
Should be
good.
R.
So the range will be what you said is correct. It is u cos theta minus alpha into t. It will take you away, and then half g sin alpha t square will bring you down. Correct?
Sir, we also have g component that u cos theta minus alpha part, no?
Pardon?
Sir, I'm talking that the u cos theta minus alpha will take it towards the right, but g sin alpha will also retard it.
Yes, that's why this is taking up, and this is taking bringing down. So this is the net value.
Okay.
Are they equal? Do we know are they equal? No. Do we know is it condition? No, this is not
No, no.
condition. This was the condition. So we were knowing that the delta y prime is 0, right? And that led to this equation. I mean, this is known to us, isn't it? What I'm saying.
Yes.
See, you started with this question because you were knowing that delta y prime is 0. This is the pre-information. So this is the priori actually. This is a priori, and then we have the posterior answer. Okay, this is the answer we know. Now today we know because this is already evaluated by the condition here. Understood what I'm saying? To begin with any rotational motion question, we have to start with a condition. Condition gives you first answer. But once that answer is available, you can create other answers, isn't it? Hello, hello. Hello,
Yes.
hello.
Yes, sir.
So do you realize that why we write the way we write?
Yes, sir.
Yes, sir.
That is very important. If any one of you had been or has been writing blindly, the chance of committing mistake is very, very high. You won't be lucky every time. So your problem solving should be thoughtful. You exactly know what you're doing. You're aware of your circumstance, you're aware of condition, and you're aware of what is right, what is wrong in a given context. So right now also you're learning chemistry, mathematics. Make sure that you learn in the same fashion. You're fully aware of what you are doing. Is this clear? So what are the other possible ways of solving this question? Because instead of this R, generally we know that this is easy to determine. If this is R, what is the horizontal displacement here?
R cos.
And we can write R cos alpha equals to how much? So to get R cos alpha, I need to only know the horizontal velocity, which is U cos alpha, U cos theta.
Yes.
And so my answer is simple, R equals to. And T I know from here. I can substitute, I'll get the answer in a much faster and efficient manner, isn't it?
Yes, sir.
Yes. You have to think that way. Or what I can do? I'll not go to that frame. So I am a geometry guy. So what I'll do is, I know that in time t you can travel u cos theta into t. And I also know that in time t you will descend. So u sin theta into t will take you upward in the same time. So the net upward movement is this much. Net horizontal is this much. Do you realize this, guys? Tell me yes or no.
Yes.
And because it's a triangle, so I could have written tan alpha equals to. And from here also I can get the same answer. Wow, so many ways. Do you realize this? The power of thinking.
Yes, sir.
And then of course I have the vector method, which you are aware of, which I have, I think, explained in the first lecture. That without doing anything, I can get the answer. Purely vector form. So those who were absent in the first lecture, for them. Okay, so when you throw something, this is alpha. So when you throw something, see, vector says that the displacement is u vector into t plus half g vector into t square. That's simple. In time of flight, what we can say? How far v naught will take? If there is no gravity, how you would have moved? This way only, no? Isn't it?
Yes, sir.
Yeah.
And in time t, you would have moved by v naught t. That's it. The first term is over. And when you reach here, let's say gravity starts from there. In the same time, gravity will bring you exactly vertically downward. So how much it will bring down?
Half capital G. Half G capital T square.
And I'm done because this is my range. This is my triangle. And I'm not bothered about any physics. I know this is theta. I'll change the color. So I know this is theta minus alpha. I know this is 90 minus theta. Do you realize this 90 theta? Maybe. This is 90. So this is entire thing is theta. This is 90. So this is 90
so
theta.
90.
And this is 90 plus alpha.
90 plus alpha.
And because it's a triangle, we can use the sine law. Now we'll say sir, sine law is not in JEE syllabus. Then we skip up to here. So there is nothing like which is beyond the JEE syllabus. So last year, it means the last year. So last year in 2022, the JEE asked a question from fluid mechanics, which he never asked before. And in fact, no one solved also. Don't worry. No one solved except some genius who had already done the Olympiad. Okay. So no one solved because but that was not part of JEE. But they can ask anything.
So what exactly was that question?
Oh, we'll come to that in that chapter. Don't worry. So what is sine law here? How to write it?
V naught T by sine 90 plus alpha. So cos alpha is half GT square upon sine theta minus alpha is equal to R by cos theta.
We are done. So if you use these two equations, we'll get the T. And if you use the first and last, the R is so we can also get the answer without touching the physics. Just a simple concept of vectors. Okay.
Yeah.
And this gives every answer in one line. But all these tricks are not useful when you solve the JEE questions. So in some situation, the way we write will be helpful. Like what is the right way of writing? What is the right way of thinking? So once you have realized everything, now I'll give you the mechanical way, like how one can do mechanically. Okay. So now mechanically you can do this way. You say the formula V equals to U plus AT. Or more especially GT. Now, depending on the convention, if I choose a y-axis upward and x horizontally, you could be anywhere here. So you may have an initial coordinate x naught, y naught, and I can throw from here in any direction I wish. So at t equals to 0, this is you here, and then at t you may be somewhere here. So what is the horizontal displacement here? And to write the one particular displacement, which is called the horizontal, you can attach. Now you can, if you solve for the given situation, this will transform into, because we don't have any x acceleration, right? And this will become so basically what I'm writing is plus half ay is how much? Because g is the value and direction is downward, so ay is minus. So when I say ay, it means what is the upward acceleration? The fact is that we have downward, so we have to put minus sign. Okay. Is this clear?
Yes.
Yes, sir.
So this is how you write the equation. You write y minus y naught. Then you have to write the vx equals to ux plus axt for x and vy equals to. So you're writing in one direction repeatedly. Like if you have two mutually perpendicular component, you can write this way. And again, this will become this much because nothing is going to change. Ax is 0. Because I have no idea about uy as of now, so I can just start like this. And then I can always add tan theta or tan alpha. And then you can solve the question. Is it clear? And to find the
Yes.
net velocity, you can add as vx I cap vy j cap, and so get the modulus. Okay. So this is how we proceed. Then you can also add the question like, yeah, this is anyway, this is vx constant. So vy square equals to uy square minus 2g. So when position is given, you go from this coordinate to that coordinate, use this way of writing. If you know the displacement, you can just write. So what needs to be substituted depends on the situation. And we are not supposed to write all this formula. You can put this formula in your brain and only substitute when on paper. So when you're solving, then you substitute in on paper, you get the answer. And if you have the relation, then these things are not required. I mean, of course, this is called mechanical way of applying the concept. If you have no idea what is happening. So you have to proceed sometime mechanically because the situation is as such that mechanical way is easier because you're not supposed to apply the brain. So it depends, like every question will have two ways of solving. One, if it clicks, then go through the shortest route. If it doesn't click and you want to solve it, just go through the process. The process will bring you to the right answer. And in examination, the process is actually more important than the tricks. Is this clear? So suddenly one fine day, I decide to give you this question. Okay. So anyway, quickly you can derive all the formula. for the oblique. Like oblique is very famous. So oblique means you throw from the level and you go back to the same level. So when level is same, then there are many special, you can say, answers which one should remember. So if you throw something on a horizontal line, we know parabola is having the property of symmetricity, right?
Yes.
So if you draw any line parallel to the vertex, it will always cut symmetrically. Okay, if you don't realize, that's okay. But can we say that because I have dealing with the symmetrical diagram, if I throw with you, when it will come back to the same level, as per the energy, the speed must be u only. And in fact, the angle will be same. Yes or no?
Yes.
Okay. So how to find time of flight? What are the possible ways in which you can get an answer? Tell me.
Y displacement is 0.
Yeah. So that's of course the one way of doing it. What else you can think of?
So that vector method.
What else? In how many ways you can think of? Like that is one way. But do you see some more ways here? Can we use the symmetricity as a tool?
Yes, sir. Maybe we can find the vertex and of the parabola.
So from there we'll get the time of flight.
Not directly, we will get the point.
Okay. So tell me at least all possible, like whatever you can think of, derive the time of flight in as many ways as possible. Okay, I'm giving you free time. Just derive
Okay,
it
sir.
as many ways as possible. Come up with some new ideas. Okay, just in how many ways you got the answer so far? Tell me. Am I audible, guys?
Yes, sir.
Yes, sir.
Tell
Yes.
me how many ways you got the answer?
Sir, two till now.
Okay.
One is basic that kinematics equations, y displacement in y0. The second one is using vectors,
Hmm.
and the third one I'm trying using that properties of parabola.
Oh, that's too much. All right. Can I carry on? Just in how many ways you got the answer?
I did kinematically, and now I'm trying parabola. I haven't
Parabola.
tried vectors yet.
No, so try vector. No? Vector is easy.
Ha.
So try it. Okay, Hasika, how many ways you got the answer?
Sir, using kinematics vectors and now using symmetricity, sir.
Okay. Tanishi?
Sir, as of now too, and now I'm trying these like somewhere relation between coefficient of roots. I'm trying somewhere quadratic properties.
Very good. That's
I did kinematics and symmetry. Now I'm doing vectors.
okay.
Sir, vectors, two methods, right, sir?
Yeah.
Okay, sir. Using velocity and displacement.
Correct. Correct.
So
Yeah.
I found one more method, like using it's kinematics only, but instead of second equation, I use the first equation, v equal to u plus at.
Okay. Very good. And about the quadratic?
I'm still trying that.
So the quadratic one I have explained many lectures, many places. See,
Sir,
horizontal
which one's
projectile is
the
something. Yeah.
quadratic?
Yeah. See, horizontal projectile is simple. In horizontal, we start from here, and here we are starting from here. That's it. Yeah. So we can write any height h. So after what time you will be here? So how much time it will take to go there? You have no idea. Let's call t. So in time t, how much will go up?
Qt minus half G. U sine t
U
minus
sin theta. U
t
minus
minus half
GT.
This will take you up, but gravity will bring you down. And the next should be
H.
All right. So every height we can travel. At two separate instant, right? T equals to T1 and T equals to T2. So what are T1, T2 here?
The roots.
The roots of the equation at which the h can be achieved, right?
Yeah.
Yes.
So this we can also write in quadratic form. How? Just don't solve only one way, because one way means you haven't explored the thinking. Rather, you have been solving because that way is just convenient to your brain. Explore your brain horizon.
Sir.
Yes.
Sir, so in this case, can we do like when H would be maximum, we can find the T for that. So time period of flight should be twice.
Yeah, I did
Right,
one
right.
more method.
Yes.
What we can take is we can write a general equation for velocity, and then when we do dot product with minus j, we must get 0 at that time period.
Why?
Because that at that time v and acceleration will be perpendicular, right, at the highest point.
Yeah.
And then double it, so we can get to total.
Yes. Very good. So how you're going to write the dot product there?
See, what you can write for velocity.
Tell me what I have to write. The
See,
answer.
u cos theta I cap plus
Dot with plus.
no u cos theta plus u sin theta minus gt j cap. And when you dot this entire thing with minus g cap minus g j cap, we must get 0 at the highest point for t.
So instead we can just make this term 0.
That's right. Yes.
But at the highest point, the vertical component is 0. That's the definition of maximum height. Isn't it?
So it's like same on that.
Yeah. So it's the same thing. When you make this 0, you get the same answer. But that is not something convenient method. I mean, convincing method. But GT square so because there are two roots of the equation. So t equals to t1 is from here to here. You know what is t2?
Capital
this
T
one.
minus 1.
No, t2 is from there to there. And because of symmetricity, if that is t1, so from here to here should be how much?
T1.
So what is time of flight?
T1 plus T2.
The sum of the root, right?
Yes.
And t is how much? The sum of the root is how much? Minus b
2
by
sin theta by g. Sir, sir, can you show that method in which we use properties of parabola?
Yeah, tell me how.
So like once while discussing a sum of, I guess, FITG advance, you were telling something about like you were showing some interesting properties of parabola using which we can
Yeah.
solve the trajectory problems.
Well, that is for the minimum time of flight and something like that.
Okay.
Okay, so what else method you got?
So vector one.
Okay. The
The
vector
equation of trajectory and then
and equation, yeah, equation of trajectory will give you time. That's not possible.
no, it will give you range and then r is equal to ux into t.
That's also there. So from equation of trajectory, you can find the range. How to find the range from equation of trajectory? Tell me.
Y equal to 0, you'll get x is equal to 0 or x is equal to the range expression.
Correct. Very good. So we have y equals to x tan theta 1 minus x by r, or y equals to x tan theta minus gx square
By
upon 2 u square cos theta.
Yeah.
And by putting this to 0, you can get a tan theta equals to g range by. So range is 2u square
Sin
cos
theta.
theta sin theta by cos theta into g. And so range is how much? Like this, right? And
Yeah.
then you want to write this as u cos theta into t. So you can do in many ways. You can see for yourself that you have figured out that, okay, once I know the condition, kinematics is about manipulation. And then the idea is to find the way which is most suitable and convenient in that situation, the easiest one. I think I was looking for one answer which you missed. So Vy I know already here. Okay.
So
So
I
Vy
this
is,
one.
yeah, I think someone used to. So because I know the velocity as well, so I'm eligible to use the velocity relation also. Of course, the displacement is 0, so y minus y naught is 0. So uy t minus half gt square is 0. And this is also organic. This will take you up, this will take you down, and it is 0. So you get the answer. Then you use the concept of time of ascent and time of descent because both are same, symmetricity again. So t is ascent plus. And we know that when you go at the maximum height, the Vy is 0. That's again definition of maximum height, which we are coming shortly here. So what is it here? U sin theta minus g into ta must be 0. So time of ascent is how much? The half of the time flight, which is obvious. And so is the answer. And of course, the vector method is there. The velocity triangle is there. So what is velocity triangle? I can put everything here. So you throw with something like u, then gt will bring it down. And this is theta at exactly when you hit the ground, it is again u and again theta, but below it. And this is your gt. This is gt by 2 half of this. So sin theta is opposite. So again, same answer. Or you can use a displacement triangle. ut. This is theta, right?
Yes, 90.
So again, sin theta goes to opposite upon
U by ut.
and all will give the same answer. So how many methods? I don't know. 1, 2, whatever, 3, 4, 5, 6, 7, and whatever you have. So there are infinite ways. I mean, not infinite, of course, there must be something, but there are many ways in which you can actually tackle kinematics. Whatever you find suitable, apply it and get the answer. Okay.
Yes, sir.
Okay. And so what is maximum height?
The point where the vertical.
See, why something goes up? Because of the upward velocity.
That becomes 0.
So gravity will never support you, no? It will only take you away. It will decrease the velocity. So as you go up, gravity will snatch your velocity and it will slow down, and eventually it will be 0. So after that, we will start coming down. So maximum height is the height at which. What is the definition of maximum height?
The velocity collinear to acceleration due to gravity becomes 0.
Yeah. So you can see that it is the height at which. Yeah, what you can say is correct. But here the maximum height is in context of ground only. So try to keep the ground into picture and then answer it. What is the maximum height in this case?
Vertical component.
Vertical component of
It is
velocity
half velocity.
becomes
0.
0. So maximum height, which means maximum height from the ground only. And if I have to say something else, I have to explicitly mention that what is the maximum height from the plane or inclined plane, or maximum height from the some other, you can say, axis or plane or whatever. But in general, when we mention the question, it is always the
respective
height at which the vertical, the ground only. So the height at which the vertical component of velocity becomes 0. So Vy is 0. See, if y is h max, implies Vy must be 0. So this is the condition from where we have to derive it. We know that this will happen. So which formula, which kinematic equation is the best to get the maximum height at one? So how to
So
get the
the
h
third
max?
one.
Yeah, the third one is the best one. So what you can write is Vy square equals to, and then this entire thing, when I teach, I write, but as a problem solving, I'm not supposed to write this thing. I will have this in my mind. I'll write 0, and I know this is the vertical component, and this is G, and this is H max. And I'll choose Y not to be original, the point of origin. So what is the H max formula? And luckily in this case, the EY is so H max is this much. Okay. Now, what is the time of flight? So it's a very common confusion that in the H max, the 2 is in here. And then in examination, if you're using the formula, the 2 will be kind of confusing statement. So you may put 2 here, there, and may commit a blunder. And then it's a blunder. So it is good to derive. That's why I say always good to derive. Even though it's a very simple answer, imagine putting 2 in the wrong place. Okay. Understood?
Yes, sir.
It is dangerous. We have to be careful. But there is something unique about the time and the maximum height. And that is what we have to explore. So both depends on the vertical component, right? So both requires the. So it means what governs the time is also governing the H-max. Hello, hello, hello.
No.
So if I have a ceiling and a floor, let's say if I throw a projectile, one goes this way and another goes this way. So do you think they will take different time or same time?
Same time.
So why both will take the same time?
They are both rising up to the same height, right?
Yes. Which means
Which means that
Vy
that
is
time
same.
period will be the same.
because they have same maximum height, which means same vertical component.
Yes.
So the time of flight depends on the vertical component velocity. Because of the difference in the horizontal component, one has traveled farther, another has traveled lesser. So both having same what? So both will have the similar time of flight. I hope you realize this.
Yes, sir.
So the diagram speaks a lot. You can convert to EY in fact. And put it here. There is a direct relation of H max and time of flight. So H max is GT square by 8. So the T is how much? Again, if you remember it is good. If you don't remember, it doesn't matter. You should be able to derive it like this. What is the definition of range? What is the form of range? How we write? So we got the answer range equals to U and T. And what is T?
2UY by G.
So writing range in this way for this horizontal oblique projectile is very important actually. So when you know the component, it's very interesting. It's a twice of the product of component upon G. So product of component, that's interesting. And then you substitute to get the answer. U cos theta, U sin theta. And so you get the range as U square. So what is the maximum range? Because the ability to throw something is fixed. So I can throw something with a fixed ability. So the maximum I can throw is when sin 2 theta is 1. It means theta is. So when you throw something at 45 degree, you will get the maximum possible range, right?
Yes.
Yes, sir.
So you might have seen in cricket there's something called almost horizontal six. So batsman hits, pushes keeps the bat at some angle, and if the ball traces the 45-degree path, with least effort it can cross the boundary. But there's a risk of catch also because it's going at low level. So the boundary player may catch it. Okay. So from the oblique projectile, there are many questions which comes as a fact based, which you should know that the range are equal when so if you throw something with constant speed u and they have angle, let's say alpha and beta, so it will go like this. So when range will be equal?
When
Sum
alpha
is
is
pi by 2.
complementary. Yeah.
Correct. Even alpha and beta are complementary of each other. So alpha plus beta is 90. No, because U is same. Alpha, beta are different. So they will have same time of flight or different time of flight.
Different.
Different.
So how to write T1?
U sin alpha. 2U sin alpha by
2u
G.
And
sin
T2?
beta. 2u sin
2U
beta by
sin
G.
beta by G.
Sin alpha will be greater than sin beta.
Okay. But alpha plus beta is 90. So can we express only in terms of alpha?
Yeah, we can write that in
Yes,
cos
sir.
Cos
beta, cos
alpha.
alpha.
So what they will give you if T1, T2 is given, can we find U itself?
Yes, sir.
Yes. What is U? How to get U? Tell me.
So we can square and add.
Exactly. So to get rid of sin and cos, you have to simply square and add.
Yeah.
And once you get rid, so what in such question they will give you time of flight, and will ask you other parameters like alpha, U, range. So can you give me all the answers? What is range here? What is alpha here? What is U here? What is U? U for type.
G square by 4. T1 in the bracket T1 square plus T2. Then,
The U is this much, right?
yes. Sir.
Because when you square, the U is U square, so to take the root, right?
Yes.
So what is the tan alpha?
T1 by T2.
And what is the range? Tell me. What is range?
So in what terms do you want? Like alpha, beta, T1, T2.
Yeah, in terms of T1, T2 only, because that is the only parameter given to us. The rest is not given.
Oh, okay.
Sir, G T1 T2 by 4.
By 4 by 2, just check.
Okay. By 2, sir.
Yeah. Very good. And
Yes,
they
sir,
will also
GT.
have the different time flight, different maximum height. So they have one, it will have the H1 maximum height. So they have different maximum heights. So instead of T1, T2, if I give you H1, H2, can you find the same thing again?
Yes, sir. So like we can directly replace T with root of 8h by G now. Sir, we can replace T with root of 8h by G.
Which T?
Sir, like T1, then H1 would be there. So like corresponding.
But let's say T1, T2 is not given. I mean, you start From the basics, the problem is again the same. If H1 H2 is given, you start with H1 H2. No? Write a question which can make sense from H1 H2 and from there think.
Okay. So actually let's solve this just using.
No, that's why this is called biasness. Once you are solving one something, then you get a biasness towards one particular thing and then you try to carry the same thing. Every time you get a formal question, you have to only start from that question.
Okay.
Yeah, make sure that this is the habit. I mean, in examination, do we get the question like this? That the question number 1 will be having some effect on the 2?
No.
So if you read every question and if you're not trying to create answer from there, if your answer depends on some previous information, then that's risky.
Yes.
Yeah.
So.
Yeah.
Say the U value is under root 2G H1 plus H2.
Correct. Very good.
Say in R4 by H1 H2, sir.
R?
Sir, R value is 4 by H1 H2.
Like this?
1 second, sir. No, sir, 4 under root H1 H2.
Yeah. And what is tan alpha?
Sir, under root H1 by H2.
Very good. So once you're done, let me know. Just you got the answer?
Yes, sir.
Josh, are you there?
Yes, sir.
You got the answer? Hello, hello, hello. So you got the answer, yes or no? Okay, so for this question, what will be the equation of trajectory?
So in which question? H1, H2.
No. The regular question when you throw with. So if you're passing through point X, Y, then how to relate X and Y? So what is X here? X equals to what we should write here?
U cos theta into T.
T.
And Y equals to?
U sin theta T minus half GT.
And then you can substitute T from here.
Yes.
So what do we get here? Y equals to?
U sin theta x upon U cos theta. I mean, U will get cancelled. Tan x tan theta minus half G
Cos square theta by
x square by square
U
cos
square
square.
cos square theta.
We can write it as sec square theta.
Yeah, you can write in lot of many more ways. So
This is the standard equation, right? Stands for theta.
we can write a Y equals to X tan theta 1 minus X by R. Okay.
Yes, sir.
Understood.
Yes, sir.
So these all formats are important. Then you can differentiate the equation and get many questions solved. So imagine there's a question. So we have so there's a tall building opposite to the road. And because of the recent layoff, the disgruntled employee starts throwing the stone from the other end. So when you start throwing the stone, it may hit at any height because the road length is finite and the ability to throw the stone is fixed. You want to hit the building as high as possible, let's say. So let's say your office is on the higher floor, so you want to damage the glass pan. Question is how high I can hit. What is Y max? So how high you can hit? Solve it. And before you solve, tell me you can tell me if you know how to solve. Tell me what will be the approach. So who will tell me the approach?
We'll differentiate the equation of trajectory to find the theta for y max.
Yes.
And then we'll continue from there.
So do it. That's easy. I hope you all know the differentiation.
Yes.
Okay. Please go ahead and tell me the answer.
Sir, in the question, do we know the angle of projection?
Think about it. You have a stone in hand, you know your ability, which is finite. So with your all might, you can throw something. So you have to maximize the height, then what will vary?
Theta.
So it means theta is the variable which you have to choose to get the height maximum, right?
Yes, sir. Yes.
So why it should be given?
Got it.
Yes. Yeah, just tell me.
Sure, I got the method. I'm still solving. Just a second.
Okay, very good.
Sir, should we find the theta or the y max?
You first find the theta, then find the y max.
Okay, sir. Sir, I got the theta.
Okay, message me.
Okay, sir.
Yeah, I think that's correct.
Okay, sir.
Then you can only substitute in the formula to get the answer, right?
Yes, sir.
So when you have a function, then you know what to be done, right? It's simple differential calculus concept. And if it is still getting wrong, then it's a serious problem. Yeah, that's correct. Correct. Just what's your answer? Just
So I sent you a photo.
yeah, that's correct your answer.
Correct, right?
Correct.
Sir, I've sent you my answer. Is it correct?
Hmm. Something, I don't know how you have written. GD square by 2u square. No, this is not correct. Have you rearranged everything and then you have written? Per you have to write in terms of only U and G and D, right?
Sorry, sir. Sorry. Got it.
Yeah. Okay. Do you guys remember the maximum range of the plane?
I guess 45 degree.
Of the plane, not on a horizontal ground.
Just a
So you know how to find the range, right? Up the plane, down the plane.
Yeah.
Yes, sir.
So what is the maximum range possible? So if you have inclined plane at angle alpha, you want to throw something at any angle. Angle you can choose. But I just want maximum range. I want a range to be maximum up the plane. This I want to maximize. So what is the R max?
Just a second. Sir, when the angle of projection with respect to the ground is 45.
No. What you are saying?
No, actually it was
Sorry. It should be
45
See,
45
plus.
plus alpha
you
by 2
all
plus
have to
alpha by 2.
derive it. Don't say me the answer which you want.
Actually, I know the answer, but I'm deriving it right now.
With you, that is the biggest problem. You know the answer. That is your
Sir.
weakness.
Hello.
Yes, that's true.
Sir, it should be plus alpha by 2 also. Just for Sir, maximum range now on the inclined plane. Just a
It is how much you said?
Sir, I'm getting pi by 4 plus alpha by 2.
That's correct answer. That's right.
And range would be u square by g bracket में 1 plus sin alpha.
You derived?
No, I'm deriving it.
Do it fast. I want derivation in 2 minutes. Done, guys?
Yes, sir.
Okay.
Say till alpha value I derived. I have to substitute it in R max.
No, that's not required. I mean, that's even easier. Even alpha is not required. Nothing is required. So we have done this question, right? What are the
Yes.
range formula which when you got the answer is G by U square by G cos square alpha, right? Into
Sine
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 2
2 theta minus alpha plus
minus sine alpha.
because it is plus
So
minus
shouldn't
alpha.
it be
Minus.
plus?
No, no,
Ah.
plus
Plus,
minus
plus.
alpha.
But
Plus
we write it
sine
as
minus
minus
alpha,
sine
which is
alpha.
minus, right?
Ah,
So eventually we get the same answer.
yes.
Yes.
Now alpha is not a variable. Alpha is a fixed. The plane inclination is constant. You can't change that. So to maximize the range, what we have to do?
Differentiate it.
Sine. No need. Sir,
No,
that 2 theta minus alpha should be pi by 2.
just we have to make it
Yes.
1. That's it. Because the maximum possible is when
Ah.
this is maximum. The rest is constant. So the
Yes.
R max we can simply write as U square 1 minus sine
And
alpha
what I
upon-
did next was cos square alpha. We can write as 1 minus sine square alpha.
Yeah, correct.
So we will get as 1 plus sine alpha. Yeah, that's it.
And because this is 1, so 2 theta minus alpha is 90. So theta is is this clear?
Yes.
So the maximum range is only this much. U square by G 1 plus alpha. And when you do the down the plane, then it is. So you can again derive it, but answer is 1 minus. The only difference is minus. And that's logical. When you go down, it will travel more actually. So to travel more, you have to make the denominator less. So it's minus. And when you go up, the gravity will also slow down. So it will be less. In coming down, gravity will support. So you will go farther, right? So with the same effort, you can throw something really far down the plane, then up the plane. Is this clear?
Yes.
Well, so now the
Yes.
question. So you solved the previous question with a lot of effort. But now, so you want to hit the building as up as possible, right?
Yes.
So when you try to maximize the Y, in turn, you maximize the range also, right? This inclined range, isn't it?
Yes.
Because if Y is maximum, see, this is constant, D is fixed. So as Y will grow, this length will grow, right? So a corresponding Y max is the corresponding R max, isn't it?
Yes.
And if I say this is alpha, and we know the answer. This answer is how much? What is R max? U square by G 1 plus
Sine
sine
alpha.
alpha. But R max itself is how much? Okay, anyway, I can first do the in terms of Y, we can write, or R max we can write as under root of D
B
square
square
plus
plus.
Y max square, correct?
Yes, sir. But I guess using trigger would be easier.
Yes. So now sine alpha we can write as what?
Y max upon R max.
Well, let's call this R as of now. That's easy to first solve. So the answer is R 1 plus Y. Yeah. Am I right? So I can multiply, right? R into R plus Y, and this is U square by G. Correct?
Yes.
So R is how much? It is Y square plus D square. And then you can square both sides. Can we do it better? R into 1 plus Y. Okay, you can square both sides here itself. But it is still, I think this is going to be bigger only in terms of calculation, not any respite. Just a minute. Oh, sorry. U square by yeah, that's fine. You have to do this only. So this is anyway very easy. So 2y I don't know why I'm writing so much. Okay, that's the answer. So you got it. This is the answer, right? And you can see you got the y max directly without substituting, right? So earlier we were substituting first tan theta. So you differentiated to get the tan theta and then you substitute to get the answer. Now here we can do it directly using the maximum range formula. So sometime if you remember the information, you can do it faster. So this is something very powerful if I have to solve question like this. So there was a similar question. I will take only 5 minutes, then I'll stop this lecture. So we know the maximum range from the bottom, but if I ask you what is the maximum range if I throw something from here? So I have some object and I would like to throw at some random angle, which is video, and I want to maximize the range. So what is the maximum range? Any guess? And here you can't apply the formula, you know, what you did, that maximum range is U square by G, by 2G, I think. No, by G only. So oblique formula will not apply, right? Because you're throwing from height. So now you have to first find the range as a function of theta and then maximize it, which is really cumbersome. So somewhere we have to use the relation. If I want to maximize the range, so as R will grow maximum, this will also become maximum. So it is equivalent of maximum range down the plane, isn't it? Hello, hello, hello. And you know the R dash maximum formula. What is R dash max? Tell me.
U square by G 1 minus sine alpha. So
That's it. And the rest you know the game. So R dash you can add as H square plus R square. I'll just like to add this as this is R only. And then okay. You simply multiply, okay, I'm writing so much. So R dash so R dash minus H equals to U square with G. So R dash is how much? It is clear? And this is correct, no? So R dash meaning. So this is this much. Okay. Because here H is given, so you can square both sides. So you get H square plus R square equals to H square plus H. And this gets cancelled, which is like the relaxation. So the R is basically under root of so you may write this as which is really nice answer, right? So the maximum range is this much. I hope this is clear. So it is simply U square plus 2GH and this U by G. So this is a very challenging problem, but if you know the inclined plane, you can get the answer. Okay. So we have almost touched the major part of projectile motion. And I think I have shared the sheet of projectile as well separately. Can you see that?
Yeah.
In the new group, I think I have shared everything. Okay. It's not there. Okay, if it's not there, then I'll share as of now.
So it's not there.
Yeah, this time. So yeah. So now I have shared you. You can see now. There are many things which I haven't discussed because that is not required. For every question I'm not supposed to discuss. I have given you the sufficient idea how you can approach any question. So now your job is to solve exercise 2 completely end to end and ALP.
In the sheet you just sent?
Yes. Exercise 2 and ALP, try to finish all questions.
Okay.
in ALP, don't try to see the answer, because I think for ALP they give the answer, which is not good. You should not watch it. And because try to solve the way you think, because the way you think will persist forever. But the way the question is solved may not come to your mind when you are solving. So that way you can develop your ideas. And once you're good with projectile, then you can play with components. So a lot of things will be built up in your brain. So your analytical ability will improve drastically. Okay.